Welcome to lesson 5.4. In this lesson, we're going to talk about all things ellipses, aka ovals. Now, before we get started, just like we've done in all the other lessons, let's cover our main vocabulary for this lesson. So I'm going to use this ellipse on your notes to go through this vocabulary. First point we have is the center of the ellipse. And very much like a circle, that's going to be at H, K, where you flip the signs and that's the center. So very like the circle or the vertex on a parabola. Now, we have two axes that we talk about with ellipses. We have the major axis, which is basically the bigger axis. So here's my major axis. And we also have the minor axis, which is the smaller axis. So you can see if you had an oval that instead of facing side to side, faced up and down like this, this would now be your major axis, and this would now be your minor axis. Major is just always whichever one is bigger. Now, the points at the end of these axes also have a name. The points at the end of the major axis are called your vertices, plural of vertex. We have two of them. And the points at the end of your minor axis are called your covertices, plural of covertex. And the last important thing that we need to talk about is our foci. I never know how to say it. Two, plural of focus. We also have two of them. Now, in a parabola, we only had one focus, and in an ellipse, we have two. Now, a couple things to notice about these foci. Number one, the foci will always lie on the major axis. So if you have a parabola that's going up and down, your foci are going to be like this. They will always be on the major axis. Number two, these points will always be between the center and the vertex. They'll be somewhere in here. If they're closer to the center versus farther away from the center, that determines how skinny or round your oval is. And we'll talk about that in today's lesson. But those are our main 6 vocabulary words. With that, let's look at an equation for an ellipse and label where we find all these things. So first, there's our H and K, so there's our center, just like we have with a circle or like we have with our parabola, H and K. Now, your major and your minor axis will come from A and B, and it will depend on whichever number is bigger. If A is bigger than B, then A is your major axis, because the major axis is bigger. If B is bigger than A, then B will be your major axis because B is bigger. So either way, you just look at whichever one is bigger and that will tell you what it is. So I'm going to kind of highlight them both and make a little chart here where I'm going to say if A is bigger versus if B is bigger. We have our major and our minor. So if A is bigger, that's your major axis, and B is your minor. And if B is bigger, that's your major axis, and A is your minor. So whichever one is bigger, that's the major axis. Now notice that the number in these equations is a squared and b squared. So kind of like we had with the radius of a circle, we will need to take whatever this number is and square root it to get what the axis actually is. And it's that amount of axis on each side from the center. Okay, so those are the only things that your equation gives you, but you will also have this equation right here given to you in your notes, this C equation. And that C equation is the equation for the foci. This is how you calculate how far away the foci are from the center. So what I'm actually going to do is I'm going to make a little more space here. Oh no, too much. I'm going to do minor B, A, I'm going to do the foci. So if A is greater than B, it's A squared minus B squared. If B is bigger, then it's B squared minus A squared. Either way, an easy way to remember this equation is you always do the biggest one squared minus the little one squared. Basically, we're making sure our root doesn't give us a negative number. If we started with the small one and subtracted the big one, we'd have square root of a negative, and we don't like that. So we're basically starting with whichever one is bigger, so we don't have imaginary numbers. So that's our foci equation. And that should be all the vocabulary we need to graph an ellipse. So in the next video, we'll actually go through and practice using all this vocabulary from an equation to graph all of these things.